Hi everyone, here is your video answer key for showcase number 9, and let's go ahead and just get started. So I'm just going to get a piece of paper to go under here. In our first section, we will be going from standard form to vertex form. So the key thing here is just realize what vertex form looks like, and to do that we're using this operation called completing the square, which, remember when I wrote this out, we're putting squares in our problem. So in order for this to work, when you group your x's together, remember to add the box in the parentheses as you group your x's and subtract the box outside of that. And make sure that you're keeping this -3. Every now and then I get some people change it to +3. But now we don't complete the square unless it's x squared. So whatever's in front always factors something out. So here we'll take out the negative, or maybe you want to take out a -1, which means when you go here, you're actually dividing everything here by that negative or that -1. So when you do that, this just becomes x squared. The next term is now minus 10x. And then everything else I'm just going to copy as I see it. And now I will take this -10, cut it in half for -5, and then I'll square -5. If you're letting your calculator help you, put that -5 in parentheses and then square it. And I get 25, which will go in here. But don't put 25 in the other one, because we've got the bunny hop of -1 times 25 to go in here for a -25. All right, we are ready to put this into vertex form. So starting with A, our number in front of the parentheses is the negative or -1, whichever you prefer. And then I will put the x in there, and just remember whatever is in front of the squared is what is in front of the squared. And then here I will be taking -3 and subtracting -25, which turns into -3 plus 25, which will give me a positive 22 here. All right, the next one. So again, I'm going to group my x's together, add my box, and subtract my box. And this is x squared. Go ahead and take something out. Just take out a 1 then. And we will take the 6, cut it in half for 3, square that 3 for 9, which goes straight up. And then if you bunny hop it, 1 times 9 is still 9. And now you can write your vertex form. So my A, the value in front of the parentheses is 1, which technically you don't need. And this time in front of my squared, I'll put a 3, a positive 3. And then when I have 2 take away 9, I get -7. All right, let's move into the next set. How do I go from standard form to factored form? So we are factoring completely. I wrote this here. Please don't forget the first step of all factoring is GCF. So when I look at my first one with 3 terms, I notice I can take a 2. I can factor a 2 out of all of these. So I'm going to write that here. And I'm going to write it here. And then I can also take an x from every term. So when I do that, I'm left with 2x squared. And then here I'm left with 9x. And then here I'm left with a -5. And now with this being 3 terms, I'll make my x. I need factors of -10 that get to 9. So those factors are going to be 10 and 1, with the 1 being negative. And now this 2, and the x, I forgot to put the x there, my GCF is just coming along. And now I'll make my factors, or my parentheses, or my neighbors, and go ahead and put x and x in there. And it will need to be a 2x in one of those, because when this first term meets this first term, you will need that first term. And now I'll go ahead, make my parentheses for my face, or my loops for my face. And x can make either one, so I won't start there, but 2x can make the 10x. And so I'll follow that with a +5 to make the 10x. And then x will follow this loop to make -1x, and that would be a -1. And now you have factored this one completely. On the next problem, again, I'm going to look for a GCF. I don't see a number I can factor out, but I can factor an x squared out of both of these. So I'm going to write that there. Here's the x squared. So when you take the x squared from here, you're still left with 4x squared. And when you have something and you divide it by itself, it is worth 1. There is something there. It's not 0. When you have 2 terms, you want to check for that difference of squares. And this is a difference of squares because they're subtraction, and these two terms are perfect squares, which means they have nice square roots. So here comes the x squared, the GCF. But now when I make my factors or my neighbors or my parentheses, the square root of 4x squared is 2x. And then the square root of 1 is 1. And I will put a plus and a minus, and now I factored that one completely. On number 5, we did change this to a negative 12. So what I'm going to do is first factor out, look for a GCF, and I notice I can factor out a 2, but that's it. So I'm going to divide everything here by 2, that's factoring out. Here is that 2. And then I'm left with 3x squared. In this term, I'm left with minus 7x, and in this, I'm left with minus 6. So with these three terms, and I make my x, I'll be looking for factors of negative 18. That get me to the negative 7, and that would be a 9 with the 2, and the 9 would have to be negative. So here comes my GCF, just joining, and then I'll go ahead and make these. And when I put my x's in there, x and x will not be enough to make 3x squared, so I'm going to have to put a 3. And then when I make my base, to make these numbers, x is never picky. X can make 2x, x can make 9x, but 3x can only make the 9x. So 3 times what, or 3x times what makes the negative 9x? That is a negative 3, so that takes care of that one. And then x times what can make that 2x, and that is a positive 2. And now we have factored completely. All right, now we're going to start the solving. So good idea to use your map. And when I look at these two problems, first these are cube problems, so I'll have to cube root. And just remember on your calculator, the cube root is under math. It is the 4th option. But these are both one type of x, so I'm just going to work at isolating x. So first I'm going to subtract 5. And that's going to give me negative 54. And then I'm going to divide by 2. And that gives me a negative 27. And now to undo that cube, remember I've just been working backwards in my order of operations. I moved my addition, subtraction, my multiplication, division, and now I'm going to get rid of that exponent with its proper root. So I'm going to cube root both sides, and when you access the cube root, again, just press the math button, choose option 4, you can put in your negative 27, and you get negative 3. And this is where my answer will only be negative 3, because 3, if I try to cube 3 times 3 times 3, I actually get a positive 27 when I need a negative 27, so there is just one answer. All right, next one, addition, subtraction. Let's write these rules. So first I'm going to subtract my 7. And that's going to give me 256. And then I'm going to move my multiplication, division. I'm going to divide by 4. It's supposed to be minus. That's going to give me 64. And now to undo my exponent of a 3rd power, I will cube root both sides. And when you do that, you get 4 on your calculator, not negative 4, because negative 4 cubed, so negative 4 times a negative 4 is a 16, and 16 with a negative 4 would be negative 64, and I only want 64, so just 4. And then I quickly add that 2 over, and then I get my answer of x equals 6. All right, moving on to the back. So here we are solving, but this time we're using with quadratics. So again, one type, more than one type. This is more than one type. I do need to get it in standard form, so I'm going to quickly subtract that 9 over. And I will look for a GCF because I'm going to try to factor first, which there is not one. But now when I make my x, I need factors of negative 9 that make 8. Those factors would be 1 and 9, with the 1 being negative. I'm going to make my factors, or my neighbors, my parentheses, and x, as it turns out, is all I need to make that x squared. And then when I do my loops for my base, I can use this x loop to make negative 1x, and then I can use this x loop to make the 9x. And then when you're done, just remember, set your your factors equal to 0. Here I would subtract the 9 over, so there's one answer, and then I would add the 1 over for my second answer. So my two answers are negative 9 and 1. On the next problem, there is just one type of x, so I will be isolating that x. Here are my steps. There is no addition subtraction because I can't get to that till I get to the parentheses, so I'm going to divide by the -2 first. And I'm going to get 8. And then to undo the squared, I will square root both sides. And I'm just going to show you the most simplest way to do this. And I'm just going to take the square root of 8 on my calculator, get that decimal, so 2.83. And when I do square root, I do have a negative version of it. And now I will make two problems out of this, x plus 2 with 2.83. So I'm getting rid of the stuff in the parentheses. And x plus 2 with negative 2.83. And now I'm going to take 2.83, subtract 2, and I get 0.83. There's one answer. And then when I subtract 2 here, I get a negative 4.83. If you would like to hear about a different way to write that answer, then just seek me out. But for the video, I'm just going to leave that. And that's supposed to be a 3. All right, next problem. There is more than one type of x, and I do want to get into standard form, but I want to keep this 2x squared, my line leader, positive, so I'm going to add the 3x to the other side. And now I'll look for a GCF. There is not anything, and when I make my x, I'm going to get negative 8x squared over 3x. And when I look at my factor list, this is not factorable. So we're going to use the quadratic formula. Here is everything set up. And that is on your map, x equals opposite of b, so negative 3 plus or minus, and now I'll take this b value and square it, so 3 squared is 9. There's the minus 4 times my a times my c, and then all of that is over 2 times a, so 2 times 2 is 4. From there, I just focus on what's in the check mark. So I do the multiplying first. 4 times 2 is 8. 8 times, which you can't see it now, is negative 4 is negative 32. And then when you have the 9 subtract negative 32, it actually becomes 9 plus 32. So inside that check mark, you get a 41. And that's all. That's how you can leave your answer. On the next one, I have just one type of x. So here goes my little checklist. And I'm going to draw my wall, and the addition subtraction I'm going to move is add that 36 over. And then the multiplication and division I'm going to move is divide by 4, so that leaves me with 9. And now to undo that exponent, I will simply square root both sides, and my calculator will tell me 3, but I'll have to realize that negative 3 is also an answer. All right, next two, we're still solving, but this time we're going to have alligators. One's squared, one's cubed. More than one type of x, one type of x. So for this one, I am going to get into standard form. I'm going to add that 28 over. Whoops. Sorry, not paying attention. That should be plus 28 with my inequality now. And I'll look for a GCF, which there is not one. So since there are 3 terms, I'm going to make my x. I'm going to get factors of 28 that make negative 11, and that would be a negative 7 and negative 4. And now when I go to my parentheses, I can put those x's in there, and x is enough for x squared. And then I can do my face loops to make these numbers. And I'll have this x with a negative 7 make negative 7x, and this x with a negative 4 make negative 4x. And then when I set them equal to 0, I'm going to get 4 as an answer, and 7 as an answer. And now because there is an alligator, I will see where the alligator is going to be happy. So 4 and 7, and the easiest number to test will be 0, which, you know, if I did graph this, I'm looking to see if it's in the parabola or outside. The easiest number to test is going to be 0, which happens to be over here. So we are going to see if he likes to be outside of it. And when you put 0 in for x and square, you get 0. When you take 11 times 0, you get 0. So when you are done, this is what your alligator is seeing. And your alligator is happy. 0 is bigger than negative 28. So it likes to be here, and it likes to be here. And now I can write my answers. So for this one, it would be from negative infinity to 0. And the other one would be from 7 to infinity. Parentheses around everything because this is not underlined. At least I don't think it was. Maybe it was and I covered up, but I don't believe it was. So if it was underlined and I can't see, then change those numbers to having brackets. Sorry about that. All right, this one is one type of x. It is a cube. So I'm going to write my little rules here. First, I'm going to add the 1 over. That's going to give me 128, and then I'm going to divide by that 2. That's going to give me 64, and I'm going to cube root my problem over here, so that's going to give me just 4, not a negative 4, and now when I subtract my 3, I get 1 answer. Now, here, when we test our alligator, a cube problem graphs like this. And so I want to see where my alligator would be happy. Probably the best number to test in this problem would be a -3, which would be over here. Because if I put -3 in here, -3 plus 3 is 0. And when you cube that 0, you still get 0. And when you take all of that, which is 0 times 2, you still get 0. So basically what happens is this whole term just disappears if you put -3 in. And then this is what you get. And is your alligator happy? Is -1 less than 127? It is, so it does like to be on the side where we were testing. And I would just say from -infinity to 1. All right, in the last problem, we will have to be going to Desmos and typing this in. So I'm going to pause so I can switch over to Desmos. So as I'm typing, I will type this in, but it does say the following function shows the parabolic path of a performer who is shot out of a cannon on a platform where h is the height in feet and t is the time in seconds. And then with that typo, these should be t's, which I'll show you in the equation in just a moment. But I'm going to go ahead and type in this equation exactly as I see it. Make sure I get enough zeros in there. And I can't put t in. I'll have to put an x. All right, and I am ready to see this equation, which, there we go. And so the first question is how long until the performer returns to the ground? So hopefully you can see this mouse. This is the mouse. You can see this is where he's starting. This is on his platform. And then he shot out of the cannon. He goes up in the air, and then he comes back down. So how long until the performer returns to the ground? I'm going to tap on my graph. This gray dot over here is where he will return to the ground, because if you notice, the y value is 0, and that's the height. The x value is the time. So under 14a, I am writing 116.144 seconds. And then in the B says, what was the performer's maximum height in the air? That's the vertex point. And I want to go for its height, so that would be the 35. And so I'm writing 35 down with feet. So let me switch back to the screen that you should be seeing. And again, so this is what I was saying, these should be t's in here, and then I wrote my 2 answers. And that is your answer for Showcase of Learning number 9.